Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Today we're going to talk about logarithms, and the first thing that we need to get to is why are we even doing this weird thing, and what is the log button on my calculator? Okay, so a logarithm is, the entire point is to solve for a missing exponent. Okay, and when we're looking at that, for example, 2 to the x power equals 8. Okay, well, we can guess and check that pretty quickly. We can go, well, x equals 3. Okay, but 2 to what power is 1,000? Okay, so we know that 2 to the 9th is 512, and 2 to the 10th is 1024. So because we can see that 2 to the 9th is 512 and 2 to the 10th is 1024, we know that the x value is going to be somewhere between 9 and 10, but now guessing and checking for it would take a lot of time. So that is the entire point of learning about logarithms, and it's to inverse the operations that we see with exponential functions. So again, logarithms are the inverses of exponential functions. So that's one of the things that we just are going to focus on right now, is just what exponent form might look like versus log form. If for some reason this doesn't hit well with you, I will have other ways of helping you understand the relationships in future videos, but for now we're going to go ahead and just actually look at where the numbers go in each format. So we know 3 to the 4th is 81. So since log form wants us to find the exponent, our exponent is 4. We have log. Now we have a subscript, so the base is going to go down as the low number. And then we have to have something inside of our logarithm, just like you have to have something inside of a radical. So this reads log base 3 of 81, and that will equal the exponent that was 4. So a to the b, c, your exponent's going to get isolated. Log, your subscript is going to be whatever your base was, and then the number that was by itself is now inside. You will not find subscript buttons on basic scientific calculators, so at this point in time, unless you've worked with logarithms and other, you probably don't know how to type it into a basic calculator. If you have a scientific calculator, it does have a subscript. Common log is a button on your calculator, and that's what the log button on your calculator stands for. And if you did log and you typed in 100, it would tell you 2. And that's because the understood base of 10 is what common log is. So when they don't write a number underneath, they assume you know that the base subscript is 10. Now look closer at your log key on your calculator. If you look into the background of it, you'll notice that it has 10 to the power. The other button that you'll sometimes see on a calculator is natural log. And they abbreviate LN. And if you do natural log of a number of 2.71828, you'll get something close to 1, and that's because I have this rounded. And that's because e to the first power is approximately 2.71828. And if you notice in the background of your natural log button, you will see the letter E. So that's because natural log and E are inverse operations, common log and 10 power are inverse operations. So if you were not going to have a calculator, how would you find out log base 5 of 125. Okay. So keep in mind 125 is 5 to the third power. See right there? 5 and 5. Well, the answer to this is 3 because 5 to the third power is 125. But some of you might have noticed that when you get the same base here and here, that you can kind of ignore it and you get your answer. And that's technically true. Log base 8 of 0. Okay. So really we're saying 8 to what power equals 0? It's a trick question. There's no solution because remember when we did exponentials, we had that horizontal asymptote at 0? The domain for any logarithm is that what's inside your, I'll call it x in this case, log base a of x, has to be greater than 0. Not greater than or equal to 0, but strictly greater than 0. Okay, so this is a little bit more restrictive than square roots. You have to have a value greater than 0. So how might you solve an equation? So 25 equals 10 to the x minus 1. Now let's keep in mind we know 10 to the first is 10, 10 to the second is 100. So 25 is between 1 and 2, so we need an x so that we wind up between 1 and 2. So x minus 1 has to be between 1 and 2. Add 1, so 2, our x value is going to be between 2 and 3, but that's not exact. So we can guess and check all day, or we can say exponent equals log base number. So we isolated the exponent, but this is a base of 10, so that's common log. I don't have to actually write it. It's just assumed, kind of like an exponent of 1 is assumed. I can type this into a calculator, and I'll get approximately 1.3979, and then I add 1, so x is approximately 2.3979, which is between 2 and 3. If you're in a class that asks you for exact answers, you would write log 25 plus 1. Okay? And again, so instead of writing log base 10 of x, they just write log of x. And instead of writing log base e of x, they abbreviate that natural log. These are just special buttons on your calculator to deal with special bases. They work the same way as any other log problem. It's just they're used so frequently they've made special buttons on the calculator. So let's look at this problem here where we have the natural log of 5x plus 1 equals 4. This really means log base e of 5x plus 1 equals 4. So this time we're in log form and our x is stuck inside of our logarithm, which means we need to flip back to exponent form. So remember, 4 is the exponent to our e. So e to the 4th equals 5x plus 1. We can just think of that as a decimal, and this time I'm going to leave it as exact form for now. So to get x by itself, I'm going to subtract 1. And then I'm going to divide by 5. So this is an exact answer, and if you were in a dual credit college class, probably what would be expected of you. If you're in a high school class, they're probably going to let you type it in a calculator, and you'll find out that it's approximately 10.7196. To keep rounding errors to a minimum, they do like us to use 4 decimal places. But the big idea behind this is just, do you know the relationship between log format and exponential format? So log 3x minus 2 equals 2. So what's my base? It's not written. So remember, you have to mentally think, put that 10 in. So this is in log format. I want to solve. So I need to get it over to exponent format. So my base is 10, my exponent is 2. So that means 3x minus 2 is going to equal 100. So 3x will equal 102. So x will equal 34. And you can always substitute these back in to check them. All right. One more. E to the x plus 2 equals 8. My variable stuck inside my exponent. That's when I need to log this. Okay, so I'm going to reformat it. So my exponent equals log base e of 8. Oh yeah, that's that one that we have a special button for. There's the letters for the special button. Subtract that 2. And we can type that in the calculator. And we'll get approximately 0.0794. So if you're having trouble with getting these going, make sure you just go back and you practice the here it is in log form, here it is in exponent form, here it is in log form, here it is. Going back and forth is going to be the key to being able to help you understand how to calculate these problems.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.